Millions of years ago, certain plants invented something revolutionary: nectar. It was a sugary bribe designed to attract insects for pollination. But this energy source was so rich, it attracted a new, uninvited guest. These early birds were poorly adapted for the job, but the reward was worth it. Over generations, the bird changed. Its wings grew lighter, its beak longer, until it mastered the impossible, hovering in midair. The hummingbird was born. Everyone marvels at the hummingbird's perfect adaptation. But what we often miss is the flower. The flower didn't create nectar to invent a new bird. But once that bird existed, the flower began to change too. To take advantage of this new, highly efficient pollinator, the flower grew deeper and more specialized. This allowed both the flower and the hummingbird to become more competitive. The bird's beak grew longer to reach the bottom. They shaped each other. The flower then adapts to further favor the hummingbird over less efficient pollinators. This is the hummingbird effect, an innovation in one area accidentally triggering a massive symbiotic evolution in another. Fast forward to human engineering. Take the windmill. Originally built to grind grain, it evolved when electricity came along. To meet modern power demands, turbines grew taller to catch more wind. As climate change accelerated, they became towering giants, generating clean energy cheaper than coal. But today's windmill is highly specialized for one job: providing smooth, alternating current, AC, to the grid. Because the transformers and inverters required to condition this power are incredibly expensive, the turbine's output is capped. When the wind blows too hard, the equipment can't handle the surge, or when the local grid is saturated or does not need any more power. The turbine literally turns its blades away from the wind. It curtails, leaving massive amounts of free energy unharvested. Meanwhile, in another part of the tech ecosystem, we have the electrolyzer, a machine that uses electricity to split water into hydrogen and oxygen. Traditionally, these are designed to pull steady, constant power from the grid. Because they are expensive, they operate safely and continuously at moderate currents to maximize efficiency. Even if wind energy is practically free during a storm, the electrolyzer can't take advantage of it. The cost of converting that massive surge of high-voltage AC power into DC power is just too high. The electric windmill wasn't invented for the electrolyzer. But now that both exist, a new hummingbird effect is taking place. By pairing them directly, we can eliminate the expensive power electronics. Suddenly, the windmill doesn't need to curtail. It grows even taller, capturing massive surges of raw wind energy and sending it straight to the electrolyzer. And the electrolyzer adapts in response. With access to bursts of incredibly cheap energy, steady efficiency matters less. The internal membrane gets thinner, expensive catalyst loadings go down, it evolves to handle massive intermittent spikes of current. This drops the cost of green hydrogen dramatically, making windmills economically viable in entirely new regions of the globe. Together, they are becoming perfectly adapted to handle the wild, intermittent nature of our planet. Two different technologies, reshaping each other to build a better future.